Hello everyone, welcome for Time Loop for Pilots again. For this video, I would like to present or review some formula because I have received some comments or some advice from my listener to review some formula for them. And so for this video, I would like to present about bank required for a rate 1 turn. And the second one is turn diameter of a rate 1 turn is linked from the first formula. And the third one, I think everybody already know about this one, is rate descent to follow guide slope average 3 degree equal 5%. And for the last one is outbound timing for a base turn when not mentioned on a chart. Because it's some of my followers, they would like to know more or need to explain more for some formula. So let's go for the first one. Bank required for a rate 1 turn. The question is, what is a rate 1 turn? A rate 1 turn is a standard rate turn, is also known as rate 1 turn or ROT. A standard rate turn is defined as a 3 degree per second turn, which completes a 360 degree turn in 2 minutes. This turn we know as 2 minutes turn, or we can call another one is rate 1. For the rate 1 it's 180 per minute. For this means half of circle. Follow the formula or the bank required to set on a rod depend on tourette speed and correspond of 15% of tourette speed. Like the last video before, I already show how to calculate this one and what is the key. Okay, review scan for the key. For the key, bank degree for rate 1 turn equal 15% of tourette speed. Refer to example, tourette speed 180 knots. Rate 1 turn should be 15% multiplied by 180 equal 27 degree bank to make 2 minutes turn or rate 1 turn rod. Aircraft fly keep 27 degree to make rate 1 turn. In some aviation school, they fix for the rate 1 turn but depend on the speed for student pilot. For example, speed 120, the bank degree should be like this, and 150 bank degree like this. But we know the main formula to how to calculate. I think it's easy for to calculate by ourselves also. I hope this formula would be useful for you. Follow to the next one. Next one is turn diameter of a rate 1 turn. For this one, we would like to know the diameter of rate 1 turn is referred to the first formula. For the first formula, we require bank degree. How to calculate for this one for diameter of rate 1 turn, follow to the key diameter in nautical mile equal tourette speed divided by 100 and refer to the same example. Tourette speed 180 knots equal how many diameter of turn during turn. So refer to the formula equal 180 divided by 100 equal 1.8 nautical miles. So the diameter should be 1.8 nautical miles during make rate 1 turn, or you can calculate 1 or 18 divided by 100. I think this formula is good for you to apply during flight. It's easy also to calculate. Follow the next one is rate descent to follow glide slope ILS 3 degree equal 5%. For the formula I already posted on my last video before also. If you would like to know more, you can follow or you can search a link or search to the back video. For this one, I will explain again and refer to airport chart as Pakse Airport that I would like to show. Follow to the key. Resistance equal 5 multiplied by ground speed in knot. And approach chart is 3 degree for ILS approach, and we would like to adapt or adjust during the real flight for resistance because at this sector or this one is so many workload, but we need to apply the easy formula to calculate. Refer to the example on glide slope to a speed 150 knot and tailwind 10 knot. And refer to the example and apply to the formula. Equal 5 multiplied by 160 knot equal 800 feet per minute. Because the ground speed it comes from true air speed plus or minus wind component. For the example, they already tell us for tailwind 10 knot. That means wind component already 10 knot. So how to calculate for the ground speed? The ground speed equal 150 plus 10 equal 160 multiplied by 5 equal 800 feet per minute. And you can follow the ground speed below for recommended rate 3.2 in case of glide slope outlined. But it's easy when you know 3 degree equal 5% and how to calculate 3 degree in percent, how to calculate percent to degree. You can follow my last video. Also, this formula is very good and is very useful also during the real flight, during approach. So many workloads at that time. On that time, you can apply this one. It's easy for you. Let's go to the last formula of the video about timing for a baton when not mentioned on the chart. For this one, I would present the airport chart invention or what type airport, but in the real approach chart, they publish to approach chart it from sector north to follow 15 dm and from sector south over and about to make a trade-off. But refer to the formula that I would like to present. I will show you how to calculate on approach chart that not mentioned for a trade-off. When aircraft would like to make a trade-off, about how many minutes that they will go on this heading or this track and make a trade-off follow ILS 3 degree. Follow the example ILS runway 13 QFU equal 135. Trade-off outbound 330 outbound. So what is QFU? Aviation course Q course for a magnetic heading of a runway. So you can search on internet or find out from some document on Annex. You will know what is a Q course. Follow the rule or not the rule, the key for the key timing in minutes equals 36 divided by angle track. Refer to the example. Time in minute equals 60 divided by 330 minus 315 equal 2.4 minutes. Because we would like to know angle track, we should use the radial inbound and divide it by the radial of the runway. That means 315 equal, and then we apply to the formula. So we got 2.4 minutes. That means aircraft should fly over station and outbound on track or heading 330 outbound, timing 2.4 minutes, and make a trade-off left turn to join final. This formula is very good during I apply in the real flight. It's more accurate. When I compare with VOR Pro chart, the distance is equal similar. I think this one is really good for you when you apply in some approach chart, but they not mention about outbound for Beijing. Aircraft fly over station and outbound in 2.4 minutes and then make a trade up to join final. I think you should try to check this one is accurate or not by yourself when you have a chance or you have opportunity to check. Okay, finally, thank you for watching my video, and I hope you follow my video for the next video also. And sum up for this video, I just mean review for a bank required for rate 1 turn and turn diameter for a rate 1 turn, and average approach 3 degree equal 5%, and the final one is outbound turning for a base turn when not mentioned on the approach chart. I hope our formula that I posted before and include this one also would be help you and it will be useful for you also. Thank you for watching, and I apologize if my English is not good for you. Thank you.